Good morning, boys and girls. Once again, Ross, WRNC518/WD4EHU from the Ham Radio Shop. This is the finished product. The first video that I posted was the actual build. Now this second video is going to be the performance. This system belongs to Patrick Harley in South Carolina. He requested that I build a system for him, and here is already the finished product, and now we're going to do the performance test. As you can see, I already have the duplexer tuned to the frequency, and I threw in a preamplifier in the means of doing a test. Not necessary, but in his case it might, because he has like a 500-foot tower, and there's a lot of line loss that might preamp may compensate for it. So that's why I'm throwing the preamp in here as a test so you guys can see. All right, so here's a preamp, duplex already connected to the transmitter, which is on 462-600, and to the receiver, which is 467-600. All the cabling is done, and that was already shown on the first video. And let's give it a run and see what happens. Okay, I have this radio here as a receiver to show the audio coming out of the what do you call it? Coming out of the repeater, the RF coming out of the repeater, including the audio. So when I inject the signal from the service monitor, which is already on frequency, the radio obviously will receive with whatever noise level I inject into it. So you can see the differences between signals coming in from a distance and signals coming in from up close. This test equipment is mainly several reasons. One of them, accuracy. It gives you accurate measurements, as it's a highly stable commercial test equipment used in radio shops. I used to use one of these at Motorola, and that's why I decided to buy one of these for my own, since I learned it very well. And basically what this does, it just simulates what goes on the field, a portal or a mobile. Okay, so here we go. Now I gotta make sure. I'm gonna pause the video for a minute. Okay, I paused the video for a minute because I realized that the unit was connected to the Octane network. And believe me, they would not like all the noises that I'm about to make going through their network. Good thing I realized that early. All right, so here's the test equipment. Here's the service monitor. This particular unit, as you can see, I got the window behind me, so it's kind of giving me a glare. But anyway, it's 462-600. And now I'm going to show, I'm going to start generating RF for you to see the difference. Okay, so now if you look at the generation knob here, right now it's all off. Okay, so we're going to start hitting the receiver with signal. As soon as the receiver hears the signal with the proper PL, DPL, then it's going to send that information to the transmitter. All the transmitter does is repeats. That's why it's called a repeater. It repeats whatever it's on the receiver out to the transmitter. All right, so we're shooting. Okay, as you can hear, the receiver is already picking up some RF. All right, there is the noise. It's not stable yet because it needs a stronger signal. Okay, at 0.2 microvolt, here, let me lower the radio. We don't need all that noise. At 0.2 microvolts, the receiver is picking up a signal, is decoding the PL or DPL and sending it through the Raspberry Pi and the sound card to the transmitter. This is a 50-watt repeater. Of course, there is insertion losses to be dealt with on the duplexer. It's usually 20% of what you put in, but this duplexer was tuned so well that it's at 0.5 insertion loss. So that's why it's putting out. I don't have the fan on it now because it's noisy. So you're going to be seeing this power drop rapidly as the PA warms up, and the protective circuit of the radio will start removing the voltage levels from the final transistor to protect it. Anyway, so basically, here's what we have. 0.2 microvolts, which is super high sensitivity. It's where we're at. We reduce some of the RF power. See, the receiver still pick up. That's when sometimes you hear somebody coming in and out. It's because he's on the threshold. Okay, so at 0.2 microvolt, we have a nice steady signal. It's already decoding the PL/DPL signals, sending everything through the Pi and the sound card to the transmitter. As you can hear, that's a steady signal. And right now we're at 40 watts. And if I keep it that way, it's going to go down to even 20, because the PA transistor is trying to protect itself. All right, the next test is going to be, let's start from the beginning. This is where I'm going to throw in the preamplifier in the mix. This is kind of rigged up because I didn't want to get elaborate if we're not going to use it. Okay, now I'm going to turn on the preamplifier. Let's see the light down there somewhere. There is a light. Okay, now the preamplifier is in the mix. It's getting the signal coming from the duplexer, from the antenna, sending it to the preamp, and from the preamp goes into the receiver's RF input. And it amplifies 18 dB of signal. That's quite a bit. All right, we're going to do the same test all over again. Let me let it identify.
964.
Okay, that's WRVZ964 repeater. All right, I'm going to start generating signal. Right now I'm at the off. Technically, this is accurate at 0.1. That's where the measurements are supposed to be. But look at this already. I just hit it a little bit, and look at this. Steady from way back there. Technically, according to the specs, the measurements are accurate at 0.1. Technically, this is not supposed to be accurate, but it gives you an indication. Even with such a weak signal, the receiver is already picking it up. Anyway, so I keep increasing. And at 0.2 microvolts, which is minus 120 dB, you have what I would call it 98% full quieting signal. That's what a preamp does. When you need it, don't let that fool you. Don't go throwing a preamp on a receiver without knowing this type of specifications. Something that is tangible, that you can read, that you can see what the results are. Because if you don't, you're going to be choking the receiver. And only the signals that are strong, like the song says, only the strong will survive, will make it through the receiver. So be very careful. Don't just go throwing preamps on receivers, because you'll be surprised and disappointed. All right? You need a piece of equipment like this or similar, like a nano VNA or something like that, to give you measurements. All right? Let's see where we're at. See, right now we're at 39 watts because it's been transmitting. See, the fan is here. Oh, look at the signal. Super clean signal. No spurs, no harmonics. Super clean signal, right on center on frequency. And it's set at 462.600 right there. Look at that peak, nice and clean. And the good part is that the receiver and the transmitter are going through this duplexer. This is fascinating, guys. For those that don't know, I have run 500 watts through a commercial this is a commercial duplexer, but they don't handle 500 watts. Can you imagine running 500 watts into a duplexer and receiving at the same time a signal from a radio or mobile or whatever at microvolts, and they don't mix with each other? Each one does its job. It goes where it's supposed to go. And that's why tuning duplexers the proper way is a must, because this is a result that you get. Exactly what you see is what you get. Now, I know there's a lot of repeaters out there that have a lot of desensing. And what is desensing? Desensing exactly means that your transmitter is bleeding into your receiver, so that becomes your local #1 enemy. And this is exactly what you have to try to avoid. Now I'm going to turn off the preamp. Okay. Now that's the actual signal being generated before preamplified into the receiver. See? And right now is what we left it before, a 0.2. That's doable, don't get me wrong. That's a beautiful low-level signal. Now if you back it up, obviously we're going to lose it. Most receivers start picking up a 0.1. All right, so I'm going to talk to Patrick. Let me just stop generating. I'm going to talk to Patrick after he sees the video to see if he might want to add the preamp to the mix. All right, guys, this does it. This is the WRVZ964 repeater in South Carolina. The project is 1 repeater and 4 receivers throughout the city or state. I don't know how he's going to configure that, but he has his own plans, so I'm just building it for him. And so far he already has a node that I have built for someone else that unfortunately passed. So that was a Simplex node, so he got that first, set it up at the tower, and he's getting like 60 some miles on a Simplex node. So if he puts a preamp on this one's probably going to increase the reception from further away. So like I said, normally I don't recommend a preamp, but sometimes you do need it, and sometimes they do the job very, very well, especially if you have a lot of line loss from a high tower with a long transmission line. All right, guys, I hope you enjoy the video. Sorry so long, but you know, that's the way it is when you try to explain things. 73s, have a great weekend, and I hope you enjoy your 4th of July. God bless America.